There's something fascinating about Mars. Every time we look at a new image, every time a rover sends a panorama of that rusty desert, a new question appears. And recentemente, quando uma foto de nuvens no céu marciano começou a circular, a pergunta foi imediata: if Mars has clouds, could it rain there? Today, the answer is no. The atmosphere is too thin, the temperature is too low, and liquid water simply can't exist on the surface. Any ice that melts sublimates almost instantly. But that brings us to a far more interesting question. Did it ever rain on Mars? Did snow fall? Did storms form? Did rivers flow for real, like on Earth? Or was Mars always a frozen, dry world, just occasionally warmed enough to melt patches of ice? For decades, scientists have debated this. And agora, com novos modelos climáticos, a resposta está mais clara do que nunca. So today, let us dive into what Mars really was like billions of years ago, a time when the sun was dimmer, the solar system younger, and Mars very, very different. 4 billion years ago, the sun shone with only about 75% of the brightness it has today. That alone complicates everything. A weaker sun should make early Mars even colder than the freezing world we see now. But then we look at the planet's surface and see something completely different: wide riverbeds, delta formations, basins carved by water, thousands of dendritic valleys that look exactly like places on Earth shaped by rainfall. So what happened? Were these channels carved by occasional melting of giant polar ice caps, or did Mars truly experience rain, snow, and a full hydrological cycle, just like our own planet? To solve this, a new study did something extraordinary. It recreated ancient Mars inside a computer. Using advanced climate models, researchers constructed two entirely different versions of early Mars. One, the cold and icy Mars in this scenario. Massive ice sheets stretch across high-altitude regions near the equator. Occasional warming events melt them, releasing pulses of water. Rivers would form only briefly, just enough to shape valleys before the water froze again. To the warm and wet Mars, a planet with thicker atmosphere, higher temperatures, and a water cycle very similar to Earth's. Clouds forming, snowfall in the highlands, rain falling in storms, seasonal patterns, stable rivers flowing for long periods. To planets, to climates, to very different histories. The question was, which one matches the real Mars? To find out, scientists looked at something crucial: the distribution of valley headwaters. These are the starting points of river valleys, and their position reveals what kind of water cycle created them. Snowmelt produces one pattern. Rainfall produces a completely different one. So, what did the simulations show? The results were striking. The cold and icy version of Mars produced valley networks that looked nothing like what we see today. Melting ice didn't create the right shapes, didn't appear in the right places, and couldn't explain the density of river channels. But the warm and wet simulation matched almost perfectly. The valley headwaters aligned with real Martian terrain. The networks flowed downhill in the same patterns. The shapes of the channels were identical. In other words, the rain-soaked Mars produced in the computer was the same Mars we observe with orbiters and rovers today. This means something incredible. Yes. Billions of years ago, Mars had rain. It had snow. It had clouds, storms, and flowing rivers. It had a climate warm and wet enough to sustain a real hydrological cycle. Mars was not always a frozen desert. It was once a world that felt alive. This new study doesn't stand alone. Recent discoveries connect perfectly with it. The Curiosity rover found evidence of a past carbon cycle, including the mineral siderite, which only forms under thicker, warmer atmospheres. Other rover missions found clays, deltas, and lake sediments that require stable bodies of liquid water. Piece by piece, the puzzle grows clearer: a thicker atmosphere, active carbon cycle, long-lived rivers, rainfall and snowfall, warmer global climate. Everything points to a Mars that once looked far more like Earth. And that leads us to the biggest question of all. If Mars once had rain, lakes, rivers, and a stable climate, could it also have had life? That's exactly why the Perseverance rover is digging into Jezero crater right now. Its entire mission is dedicated to finding signs of ancient microbial life, fossils, chemical signatures, sediments shaped by biology. Because a warm, wet Mars is not just interesting, it's potentially habitable. And here's an interesting detail. If you could go back 4 billion years and look at Mars from space, you wouldn't see a red world. You would see a planet with white ice caps, white snow, cloud belts swirling with moisture, river valleys carving through darker bedrock. It might not have been the red planet at all. For a time, maybe it was the white planet. Today, Mars is cold, dry, and quiet. No rain falls, no rivers flow. Its atmosphere is thin, its landscape frozen in place. But underneath that stillness lies the memory of a different world, a young planet warmed by a thicker atmosphere, wrapped in clouds, drenched by seasonal rains and snows. And through climate simulations, geology, and rover discoveries, we're beginning to reconstruct that ancient story billions of years ago. Yes, it rained on Mars, and that changes everything about how we see the planet and our place in the solar system.